Assalamu alaikum everyone. I hope you all are pretty good. So today we are going to understand one of the most important concept in database. This is stack. I will explain what a stack is, how it's work, how to implement it, and where it's used in our daily life. So before we need to start, let me introduce first, then we'll move towards the topic. Myself, Shan Rana. So today I'm going to explain stack implementation. This is a template I already have been prepared, so it will be very helpful to create, to save our time. So that's why I create it already, and the background about it I will discuss now. Firstly, we need to know what is stack. A stack is a linear data structure that follow a very simple rule: last in, first out. It's called LIFO. This means if the last atom was pushed into the stack, one that came out. So, and the real time example, we think stack like a plates. You add plate on the top and you also remove plate from the top. So you will never pull a plate from the bottom. First we need to add first in bottom, it will goes into the bottom, and the last you enter the plate will be at first, will be at top. So we cannot push from the bottom. We firstly prefer to put from the top. So the main stack operation is a stack always support three major operations: push, pop, and peak. So now we are going to say about stack implementation. We use these two concepts by using arrays, by using linked list. So we prefer, this is very easy and fast. This is used to dynamically. So this is now I'm going to start code. So firstly we create a stack with the size of 10. We always know our top will always start from -1. We always start this from -1. Then we use a function void push, and the data type, the data into D, it will be a parameter. We will pass the value from as a reference from the main function, and then we add a condition top after. We now there is a top is equal to -1. After that top is equal to top plus 1, then it will increment it. If top less than size, then stop stack top is equal to D. D value takes, give the value to the stack top. Else parts it's say it's overflow. And then next we use another function with pop. If top are greater than -1, stack pop, and top is equal to decrement. So this is an visualization memory. So top first is equal to -1 when we data at index 0 and 10, then 20, then insert 30, then 40, then 50, then 60, then so on, after that 100. So this, in this way we can add, pop, push and pop our data in our stack. The stack we mostly use in our applications in DSA. So we can say stacks are used everywhere in the computer world. Here are some common example: function call stack, undo, redo in editors. Every time you type something and hit undo, it's the stack that store the history. Parenthesis checking to check if braces, like curly, our balancing in programming, expression conveyance, infix to postfix, postfix evaluation. So the next we are going towards the mathematical expression. The operator we mostly use between two operands, it will be called infix notation. Operator after both operands likewise will be post. Then we see here is the precedence priorities of our operators. First, the highest priority we always says tier 1. Tier 1 we know that the highest priority. So highest priority of power function, after that multiply and divide have same priority. Second priority level, after that plus minus. lower priority. So now we are going, here are simple three rules we discuss, and then we will move towards our table. First priority of operator at the top of the stack is lower less than the priority of the newly scanned operator from infix one. Then simply push the new scanned operator at the top of the stack and nothing will be popped. So the next second rule, if the priority of the second operator at the top of the stack is greater than the priority of the second newly scanned operator from infix expression, then simply pop the top operator from stack and then push the new scan operator at the top of the stack. And this is the third rule. If the priority of the operator at the top of the stack is equal or same to the priority of the newly scanned operator from stack, and then push this in new operator at the top of the, this is the expression we will calculate using stack mathematical expression. Firstly, we write according to this. We see here the bracket will always goes in the stack, and digit from 0 to 9 always goes in the postfix. This is 1, this will be go there, this is here. So plus we know that is operator will always goes in the front of the at the top of the stack. This is the first operator, therefore it will be go here. And this is a digit will always jump to the postfix. And this is the minus, we know that both have same priority level, so it will be pushed into the postfix and it will come at the top of the stack. 3 is always again the digit, it will go again. This is multiply. We know that multiply has higher priority at the top of the stack. Therefore we will add at the top of the stack. Then again to it a digit, it will again goes to the postfix. And this is the main concept. Here is a divide. We know that both have same priority. If both same priority will come, then we will easily use trick. We will always push the top of the stack and pop this at the top of the stack. And this is we use to implement add another digits likewise, and the answer will become in this form. This is the all scanned elements we use to again we implement it to get a result that will easily calculate. We write it here, and firstly 1 goes there, 1, and we with 1 plus 1 1 2, we add him 3 3 plus 3 3 3 फिर 2, then we multiply, then with 3 multiply to 6, then 3 is always down 6, then 6, then 2 again divided by 2 3 6 6 6 2 multiply 6 divided by 2 36, then plus, then add him after get we result as 36. This is the our stack implementation. If I hope you can easily understand. If you had any problem, just drop a comment and give your objective.